Okay, here's the video solutions for the practice test on Unit 3 Pythagorean Theorem. It says find the length of the indicated side in each triangle. Round your answer to the nearest tenth if necessary. So these are just the basic right triangles. Use the Pythagorean theorem, substitute, do your adding or subtracting, and then do the square root. So I'm going to do little shortcuts. So I know I need to find c. So that means I know I'm going to square each of these legs, add them, and then find the square root. So square root of, or the 14 squared is 196. 12 squared is 144. If I add those up, I get 340. Then I'm simply going to find the square root. So that's between the square root of 324 and 361. So it's between 18 and 19. And it looks like it's 16 away here. It's 21 away here. So it's a little closer to 18, but not a whole lot. So a good estimate would be 18.3 or 18.4. So you'll have a little leeway when you give the answers on your test. Okay, in this problem, I know one of the legs and the hypotenuse. A common error is students will think, well, this problem is like 1, and they'll square the 3 and the 9 and add them. When in fact, you need to square the hypotenuse, 81, and subtract the square of the leg. So that would be 72, and the square root of 72 is between 64 and 81. So it's between 8 and 9. And it's, let me see, 8 away there. It's 9 away there. So it's very close to the middle. But it's a little bit closer to 8. So 8.4 or 8.5 would certainly be acceptable. Okay, number 3. So this time I'm actually going to do the full problem. I'm going to write the Pythagorean theorem. Okay, I'm going to substitute. So I know one of the legs is 4. I don't know the other leg. I do know the hypotenuse. The longest side is 5. So that's going to be 16 plus b squared equals 25. And this is why we subtract when we only know one leg, because I have to get rid of the 16, so I do a negative 16, which is like subtracting. Okay? So if you do the shortcuts, make sure you understand it, or else you need to use the actual theorem itself. So they would cancel. So I'd have b squared equals 9, and I need to find the square root of each, so I cancel out that square. So b equals the square root of 9, which we know is 3. So we call these three numbers, 3, 4, and 5, a Pythagorean triple because they are whole numbers and they make a right triangle. All right, determine whether a triangle with each set of side length is a right triangle. So what we're going to do here is called the converse of the Pythagorean theorem. Instead of finding one of the sides, we start with the sides and we work backwards to see if the theorem itself holds true. All right, so let's stop my computer from going down. All right, so 5, 3, and 12. So go ahead and write the theorem. A squared plus b squared equals c squared. Make sure you substitute correctly. The longest side, in this case 13, always has to be the hypotenuse. So 5 squared plus 12 squared equals 13 squared. Notice I'm not solving for anything. I know all of the variables. So that's 25. That's 144. That's 169. If I add 25 and 144, I get 169. And of course, 169 is equal to 169. So all three of these numbers made this statement true when I put them into the Pythagorean theorem. So yes, this would make a right triangle. Okay, let's try this one. A squared plus b squared equals c squared. So my two legs are 3 squared, 5 squared. I know my hypotenuse is 8, so square it. 9 plus, oh, that was backwards. That should be 5 squared. So that's 25. That's 64. 9 plus 25 is 34, which we know is not equal to 64. So if I had 3 boards, 3 feet long, 5 feet long, and 8 feet long, I could not use them as a right triangle to, let's say, brace up a wall. So this is no. Now I should have known that these would make a right triangle because they don't even make a triangle. According to our triangle inequality, two sides of a triangle must always add up to be larger than the third, and 3 plus 5 is not greater than 8. So these don't even make a triangle. So I'm sure you can do 6 now. All right, multiple choice. Determine which definition best describes a Pythagorean triple. Well, we talked about that in an earlier problem. So numbers that are 3 apart? Nope. Numbers that add up to a multiple of 3? Nope. We said they're 3 whole numbers, so they can't be decimals, that create a right triangle. So 3, 4, and 5, we know from our notes, are the first Pythagorean triple. Determine which set of numbers is a Pythagorean triple. Well, if I do a shortcut, I know I'm going to square this. That's 9. That's 36. And that better be equal together to be 81, which it's not. Okay, so here's my leg, 25. I'm just squaring them. I'm just doing a shortcut to the Pythagorean theorem. That's 144. This hypotenuse would be 169. So 25 and 144, yep, is 169. So that's my Pythagorean triple. Okay, which process best describes the best method to solve for a leg of a right triangle? So you write the formula, yep. Okay, you can't square anything because you haven't substituted, so that's not right. Write the formula, yep. Substitute, yep. Square them, yep. Add, no. Okay, we're solving for a leg. That means we know a hypotenuse and the leg, and we know in that case we have to subtract, so that wasn't it. Write the formula, substitute, square it, yep, subtract, and find the square root. So that's it. That's our process. Okay, a 5-meter ladder leans against a house. It is 3 meters from the base of the wall. How high does the ladder reach? Let's put our information in. Okay, so this is our ground, and obviously here is our height right there. So what we're doing in this case is we're substituting numbers in. It's 3 feet or meters from the base of the wall. So this is 3. I need to know the height. And so these two are perpendicular. They make the legs. So let's call that leg A. All right, so we know when we have a hypotenuse and a leg that we square the hypotenuse. So that's 25. We square the leg. That's 9. And we subtract them. Then the final thing always is to find the square root. Well, that's a perfect square. So square root of 16 is 4. So one of our legs is 4 meters. Okay, find the perimeter. Perimeter, got to remember, perimeter is all of the outside measurements added up. So in order for me to do that, I need to know this over here. So since this is my right angle, let's call this, again, leg A. So just like in number 10 over here, I know the hypotenuse and I know a leg. So let's square the hypotenuse, that's 100. Let's square one leg, that's 64, and we subtract. So I get 36, and then I find the square root, which is 6. Now, the common error is just to put the answer 6, but we know again we're finding perimeter, so that means that's 6 over here, and that's 8 there, so 6 and 8 is 14. Another 6 and 8 is 14. 14 and 14 is 28 units, or 28 is fine. Okay, sketch each problem to help you solve. A baseball diamond is a square with sides of 90 feet. What is the shortest distance to the nearest tenth of a foot? Well, in class we said, let's just make it to the nearest foot between first base and third base. So let's go ahead and make our baseball diamond. Okay, so that we can put the measurements in there. So we know this is a square. All right, so we know each of these is 90 feet. And they're asking us to find the shortest distance from first to third. So this is first base, second base, third base, and home for those of you who don't know about baseball. So I'm finding this distance right here, okay, right there. That's the first to third distance. Well, we know that it's a square, so that's my right angle. That means this has to be my hypotenuse, so we'll call it C. So I have these two legs. So I know I'm going to square each of them and then add them up and find the square root. So 90 squared, well, this is from Unit 2. Remember that table where we had 10 squared, 20 squared, 30 squared, etc.? So I just take 9 times 9 is 81 and add then 2 zeros. So that's 8,100 feet. That would be the same. So if we add those up, we get 16,200 feet. We know we do the square root. Now, you might think, well, there's no way I can find the square root of that big number. Well, remember, this is can act like a perfect square. We know from our work before that we forget the zeros. They'll just add on the end. So let's just work with the 162. I know that's between 144 and 169. So that's going to be between 12 and 13. But remember, this was in the thousands, so then these have to be in the hundreds. Obviously, this can't be 12 feet over here because we know that the legs are 90. So this has to be more. So what's it closer to? Well, that's 18 away there and only 7 away there. So my answer is closer to 130 feet than 120 feet. So if 125 was in the middle, that means a good estimate would be somewhere around 127, 128 feet. And there you go. Okay, in a computer catalog, a computer monitor is listed as being 19 inches. This distance is the diagonal distance across the screen, like same for a TV. If the screen measures 10 inches in height, what is the actual width of the screen? So I'm going to make a rectangular computer monitor, okay? And then I can put the numbers in there. So I know that the diagonal right here is 19 inches. It says that in the problem. I know that the height is 10 inches. It says that. So I'm trying to find the width. Well, here's our 90-degree angle. So I know the hypotenuse and the leg. So just like some of the other problems, I square the hypotenuse, 361. I square the leg, and I subtract. So that's going to be 261. And then I do the square root at the end. So that's between 256, 289. So I know my width is between 16 and 17. Now this problem is a little bit different than the other estimations. I need to find it to the nearest inch, so there isn't a decimal. So this is like our Unit 2 work where we found the closest integer. So it's 5 away here. It's actually 28 away here. So obviously it's closer to 16 than 17. So 16 inches would be the width. Okay. All right. Let's do number 14. 2 joggers run 8 miles north and then 5 miles west. What is the shortest distance to the nearest tenth of a mile they must travel to return to their starting point? Okay, well, here I am, ready to go jogging. So I'm going to go 8 miles north, we know is straight up on a map. Then I'm going to go 5 miles west, which is to the left on the map. And I need to find the distance back home, which would be right there. So we have a right triangle. Oh, computer, come on. Computer's working on its own, trying to catch up. Takes a lot of power to do this. There we go. All right. There we go. Okay, so I know that's 8, and that was 5. We know here's our right angle. So I know both legs. I need to find this hypotenuse. Remember, we square each of the legs, 64 and 25, and we add them. So that's 89, and then I find the square root of 89 would be between 81 and 100. So my square root would be between 9 and 10. Let me see, it's 8 away here. It's 11 away here. So it's pretty close to the middle, but it's a teeny bit closer to the 9. So probably 9.3 or 9.4, and that would be miles. Okay, we know from our work in class that when we want to find the diagonal distance across a three-dimensional prism like this, that we have a nice simple formula. L squared, length squared, W squared, width squared, height squared equals that diagonal squared. It's kind of a nice little formula. If I didn't use that, I'd have to do 2 Pythagorean theorems because I would need to know this distance right here in order to find this because I need, this would be my right triangle right there inside the box, that little sliver of a triangle in there. Okay, so that would mean I need to do this triangle right here on the bottom. So again, why do two Pythagorean theorems when somebody's come up with a nice little formula already for me? So the length is 6 squared, the width is 15 squared, the height is 8 squared, and I don't know my diagonal squared. So that's 36, that's 225, that's 64, and then add them all up. So this is kind of just a hybrid of the Pythagorean theorem. So 36 and this 64 over here is 100, plus that 225 gives this as 325 equals d squared. Just like in the real Pythagorean theorem, I go ahead and I find the square root to get rid of that square, so they cancel. All right, square root of 325 is between 324 and 361. Well, you can see it's only one away here, so it's almost right there. So that's 18. So a good estimate would be 18.0 or just 18.1. Now when I put a 0 in the decimal like that, that means I've rounded it. That's different than just saying 18. That means it was exactly 18, which it wasn't. So these two would be more appropriate. All right, a few more. Finding distance. So I need to find this distance. So let's go ahead and make a right triangle. So now it looks like some of the other problems I've done. So this leg is 4. This leg is 11. So I know both legs, so I square the legs and I add them and I find the square root. So you should be pretty proficient at that. So that's between 121, 144. So it's 16 away here. It's only 7 away there. So it's closer to the 12 than to the 11. Quite a bit closer. So let's call it 11.8. Okay, here. Well, I'm going to do a little shortcut. Let me see. I know that I'm going to the right 8 on this x-coordinate, and I'm going to the left 4 on this x-coordinate. So when I go in opposite directions, I'm simply going to add the 8 and the 4, and that's going to give me a 12 for my distance on my horizontal leg. I'm going up 7 on the y-coordinate and up 2 on the y. So pretend this is 0. I went up 2, then I went up 7. Well, what's the difference between 2 and 7? It's 5. So that would be my vertical distance. So now if I write that in there, I have my right triangle. So I know both legs, so it's like 16. So square the 12, square the 5, add them up, and I get 169, and then do your square root, which is perfect square, so it's 13. Okay. All right, and the last one I'll actually use the formula. Find the perimeter of the polygon. So perimeter means I have to find all the distance around. So here's my right triangle right here. There's one leg going vertical. Here's one leg going horizontal. So I really need to find that using the Pythagorean theorem. So I know this is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. And there's that. So I actually don't need to use my formula because I can just use the right triangle. So again, I know both legs. So I square one leg, 64. Square the other leg, 36. Add them up and find the square root. And I made it really easy. Square root of 100 is 10. Now, that's not the answer because I need the perimeter. So the perimeter is the distance around. So 10 and 8 is 18, plus 6 is 24. And that's the perimeter. All right, so if you need help, come in. We can do some more problems. If not, study and let's do a good job on the test.